Welcome to today's chemistry class. Today we'll be looking at the topic halogens. Kindly remember to like this video and subscribe to my channel, as well as share this video. Our end in mind for today's lesson: by the end of the class you will be able to express the meaning of the word halogen and relate such to the lesson. Discuss occurrence of halogen in nature. Mention 5 substances in daily life that contain specific halogens. Indicate the position of halogens in the periodic table. Write the electronic configuration of the first 4 halogens. Perform and demonstrate experiments on laboratory preparation of chlorine gas. So relax and enjoy the class. Okay. Did you know that chlorine was also the first poisonous gas to be used as a weapon during World War I? That tells you that chlorine has been in existence for so long, and people have been using it for one purpose or the other. Did you also know that this chlorine is one of the member of the halogen? So let's dig into what the halogens. The word halogen simply means salt formers. So when you hear halogen, it simply means they have the ability to form salts. Okay, now talking about salt in this case, for instance, we have sodium chloride, which is the common salt we use at home. Sodium chloride, the formula is actually NaCl. Now the Cl there is for chlorine, and chlorine is one of the members of the halogen. Now we have some other salts that can also be formed by halogens, but basically the common one that as a layman you can easily understand is that of the sodium chloride, which is a common salt we use at home. Okay, the halogens, they are found in group 7 of the periodic table. They are found in group 7 of the periodic table. Now, as you can see on your screen, the periodic table charts. So you will try to look towards the right hand side. You will see the chlorine there, and you also see fluorine. Then you will see some other elements of the halogens. So they are basically found on the periodic position 7 of the periodic table, and this group of elements, they are actually reactive nonmetals, which simply means they are very reactive actually, and because of this, their reactivity, they don't occur in a free state. So that's why in the sea we can't have just chlorine, we have it combined with sodium chloride, with sodium rather, to form sodium chloride. Okay, another general properties of the halogen is that they have 7 valence electrons in their outermost shell. They have 7 valence electrons in their outermost shell, and that's why they belong to group 7. They also exist as diatomic molecule. When we mean diatomic molecule, it simply means that they have 2 atoms in them. For instance, chlorine is always written as Cl2, which simply means there are 2 atoms of chlorine in one molecule. They are colored and they ionize to form univalent negative ions. Now look at this image we have here. So this image is trying to explain the valence electrons of the halogen. So if you look at the outermost shell, this shell we have here, Okay, let me start with the innermost shell. You can see the one I'm pointing at here is the innermost shell, followed by this, then this last one here is the outermost shell. So if you look at this outermost shell, the number of electrons in the outermost shell is 7. So that's electron in the outermost shell, we call it the valence electrons. So for all the halogens, they have 7 electrons, 7 valence electrons in their outermost shell. Okay, so they also form electrovalent compound with metals. Now when we mean electrovalent compounds, electrovalent compound, they are formed by transfer of electrons between a metal and a non-metal. So basically when bonds are formed between metals and non-metal, they are usually electrovalent bond, or what we also call the ionic bond. So we are now saying that halogen, being a non-metal, they can form electrovalent bond with metals. For instance, in this diagram you are seeing, we can see that we have sodium here. Sodium is a metal, chlorine is a non-metal. So now there's going to be transfer of electron, basically one electron from this sodium to chlorine. So upon the transfer of that electron, there's going to be formation of the electrovalent bond. This electrovalent bond, there's going to be formation of the electrovalent bond. So that bond is what is actually holding the sodium and chlorine together. And because of the nature of this bond, they exist as ionic compound, that is, they possess charges, the negative charges as we are seeing on the chlorine, and the positive charge on the sodium. Okay, now let's look at the electronic configuration of the halogens. First, we have the fluorine. Fluorine has the atomic number of 9. The electronic configuration is 1s2, 2s2, 2p5. In my previous video, I've talked about how we can go about writing electronic configuration of elements. So if you've not seen that video, you can just go to my channel and search for videos on nitrogen and its compound, and I'm sure you are going to get the explanation to this. Okay, we also have chlorine. Atomic number of chlorine is 17, and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Then we have bromine. Atomic number is 35, and you are seeing the electronic configuration. We also have iodine. Atomic number is 53. Then we have astatine. Okay, so all these are members of the halogens: fluorine, bromine, chlorine, and iodine. They are all members of halogen, including the astatine. So if you look at this diagram here, it shows the states, the physical states of the halogens. Fluorine exists as gas. Now when I was talking about diatomic the other time, you see that all of them, they have two atoms in them. So that's what we mean by the diatomic. So chlorine is also a gas, bromine is a liquid, iodine is solid, then astatine is also solid. So, and you can see that the boiling point increases down the group. So it simply means that out of all the halogen, astatine, we have the highest boiling point. Now out of all this halogen, also fluorine is the most electronegative, is the most electronegative. So okay, so talking about electronegativity, I also have videos on my channel that explain periodic trend. Okay, so let's talk about laboratory preparation of chlorine gas. We actually have various methods by which we can prepare chlorine gas in the laboratory. However, I must sound this as a note of warning that chlorine gas is a very poisonous gas that can affect the respiratory system when inhaled. So, one has to take precaution while preparing this gas. Preparation is usually done in a fume cupboard so as to prevent inhaling the gas. Okay, so we can actually prepare chlorine gas by heating concentrated H2SO4 with a mixture of sodium chloride and manganese 4 oxide. Look at this. This is H2SO4, hydrogen tetrasulfate 6 acid. Is an acid and care must be taken. And we also have the salt, which is sodium chloride. And we have this oxidizing agent here, which is manganese 4 oxide. So this is the chemical equation for the reaction. Having sodium chloride plus the manganese 4 oxide plus H2SO4. Then we have the sodium sulfate. We have the manganese sulfate. We have water. And then chlorine gas is produced. So this is also a method. Now we have by the oxidation of concentrated HCl with strong oxidizing agents. Strong oxidizing agents such as manganese 4 oxide and KMnO4, which is potassium permanganate. So now if we have any of this, looking at this chemical equation here, using the manganese 4 oxide here, reacting it with HCl, we have manganese chloride, we also have water, then we have chlorine gas being produced. Okay, so if you don't want to use this oxidizing agent, manganese 4 oxide, you can as well use potassium permanganate. Okay, so that talks about the two methods by which you can use to prepare chlorine gas in the laboratory. Please know that when we are talking about preparation, you should be able to give all this chemical equation to support your explanation. Now let's look at a schematic diagram. Now looking at this, we have concentrated hydrochloric acid. So basically this diagram is explaining the second method, that is reaction of manganese 4 oxide with HCl. So you can see the manganese 4 oxide here, then hydrochloric acid being added, so then we heat. So it is expected that the chlorine gas will be given off. So once chlorine gas is given off, it passes through this delivery tube. Now this gas can be dried, that is the chlorine gas can be dried with concentrated sulfuric acid, or what we call H2SO4, hydrogen tetrasulfate 6 acid. So upon drying the gas, the chlorine gas can then pass through this tube as well, and you can receive your gas by downward delivery. Now I'm sure you will be wondering that, okay, collecting this gas by downward delivery, will the gas escape? Chlorine is denser than air. Chlorine is denser than air, so it is expected that air will fill the upper parts while the gas will settle at the bottom. It's just as if you are throwing stone inside water. It is expected that the stone will be at the bottom of the water because the stone is heavier than the water. So now we're having air and we are having chlorine in this jar we have here. So since chlorine is heavier than air, the chlorine will be at the bottom and the air will be on top. So with such, you will collect the chlorine gas without it completely escaping to the atmosphere. So that's why the chlorine gas is collected by downward delivery, basically because chlorine is heavier than air. Okay. Okay, can you take a break and reflect on what we have discussed so far? Try to see if you can recall the various ways by which you can prepare chlorine. Try to learn the chemical equation, the schematic diagram. Try to see if you can also draw it. Then continue, play the video, and continue learning. Okay, so I want to discuss about the industrial preparation of chlorine. Now, basically, chlorine is manufactured industrially by the electrolysis of brine and molten sodium chloride. So you can either have molten sodium chloride or magnesium chloride or calcium chloride. In all these salts, these are actually salts. Magnesium chloride, calcium chloride, they are salts, as well as the sodium chloride. So you can see that they all contain chlorine. So it's easy for us to get the chlorine from them since they contain chlorine. Okay, so talking about this industrial preparation is actually a large scale of producing chlorine, and you know, it can just be done by electrolysis. Probably I will also have a video on electrolysis as time goes on to explain the processes involving electrolysis. Okay, so this is just a diagram to show the process of electrolysis in the preparation. Okay, so now let's talk about test for chlorine. Now, when you take a blue litmus paper, I believe you know what a blue litmus paper is. When you take a blue litmus paper and insert it in the unknown sample or unknown gas, if the gas is actually chlorine, it's going to turn the blue litmus paper pink, and after that it's going to bleach it. That is, it's going to change to white. So that's where have a kind of suspect that okay, the gas is acidic in nature. The gas that is reacting with the litmus paper is acidic. Okay, look at this illustration here. You can see like this is a test tube, and in this test tube we have chlorine gas and a litmus paper is being inserted. So you can see the schematic illustration showing that from blue it changes to red, then after which it's been bleached off from red to white. So we also have another way by which we can test if the sample or the gas contain chlorine. Then it turns dark starch iodine dark blue. Chlorine turns starch iodine paper blue because it displaces iodine from iodide. The iodine liberated then turns the starch blue. So basically this is more being specific for the test of chlorine. Now, we must have heard about chlorine being used as, bleaching agents, and sometimes part of detergents as cleansing agents. Now, but there's this particular property of chlorine that makes it be able to be used for that action. Chlorine is a powerful bleaching agent, yes, and the bleaching action is due to the oxidation in the presence of water to liberate nascent oxygen. Now, if you look at this equation we have here, it's trying to explain how chlorine does the bleaching work. Now, looking at it, this is actually chlorine. So when you dissolve chlorine in water, we actually have hydrochloric acid. Now, but because of the ability of the chlorine is going to displace the oxygen from the water, so you can see that the oxygen is standing alone here. Now, if this oxygen combine with a color substance, then it tends to neutralize that color substance to colorless. So if you have a stain on maybe a cloth or something, there's a stain, and you apply chlorine to the substance, provided that there is water present, maybe you must have dissolved the chlorine in water, and you now put that solution, that is the solution of the chlorine and water, in the substance that is stained. So what actually happens is that the chlorine will help to displace the oxygen from the water, so that oxygen can then bind to that color substance and and change it to colorless. So by uses of chlorine, it is used as a bleaching agent for cotton, wool, or pulp. So we have explained that. It is used for making domestic antiseptics, e.g. acidified sodium chlorate solution. We also have, it is used in the manufacture of polyvinyl chloride, that is PVC, and those are some PVC pipes. Most of those pipes used for plumbing work, like toilet pipes, they are PVC pipes, and they are made from chlorine is part of what is being used. Okay, it is also used in producing potassium triosochlorate for making matches and fireworks. It is a powerful germicide due to its oxidizing nature. Okay, let's look at class activity. Let's try to do some assessments. Okay, the link actually, you can't click it from the video, but you can always attempt the one below, which is explain bleaching action of chlorine. Explain the bleaching action of chlorine, then describe the laboratory preparation of chlorine. So pause this video and try to attempt this activity in your notebook. Compounds of chlorine. Compound of chlorine. So we have hydrogen chloride. Hydrogen chloride, that we also call HCl, is a compound of chlorine, that is chlorine combining with hydrogen to form hydrogen chloride. Hydrogen chloride, marine acid gas, exists as a gas at room temperature. It dissolves in water to form hydrochloric acid. So it simply means that if we have hydrogen chloride gas and you dissolve that gas in water, that's what will bring about hydrochloric acid. I'm sure you must have been hearing hydrochloric acid. Hydrochloric acid is also present in the stomach, and basically hydrochloric acid is just when hydrogen chloride gas has been dissolved in water. So that's how hydrochloric acid is being formed. Okay, so let's talk about the laboratory preparation of the HCl. The gas is prepared by the action of hot concentrated H2SO4 on any soluble chloride. For instance, a soluble chloride here could be sodium chloride. So when you react H2SO4 to sodium chloride, with sodium chloride rather, we form sodium sulfate, then hydrogen chloride gas. Please note that when we are saying hydrochloric acid, that's an acid, but when we are saying hydrogen chloride, that exists as a gas. Okay, the hydrochloric acid is usually in aqueous state. So this gas is dry by passing it through concentrated H2SO4 in another flask and is being collected. So this is a schematic illustration here. Looking at this, we have concentrated H2SO4 being poured inside the sodium chloride in a flat bottom flask. So this is actually a flat bottom flask. This is T2 funnel. Then you can see the H2SO4. Then we have the sodium chloride. So upon adding all this, a reaction will occur. So hydrogen chloride gas will be released, and this gas can then be dried in another jar here where we already have concentrated H2SO4, what we also called sulfuric acid. So then the gas can then be collected by downward delivery. Okay, so both chlorine gas and hydrogen chloride gas, they are collected by downward delivery because they are heavier than air. Industrial preparation of HCl. Pure HCl gas can be produced in large scale by direct combination of hydrogen and chlorine gas obtained from the electrolysis of brine. So this is just a chemical equation for that. Test for HCl. Now basically, when we can test for HCl by just having a glass rod. So if you have a glass rod and you dip that glass rod in ammonia, concentrated ammonia solution, aqueous ammonia, is going to you will see a white film around the glass rod. So that tells you that the gas is hydrogen chloride gas. So you can see the illustration here. Hydrogen chloride gas, then this is a glass rod. So here we have aqueous ammonia in this container. So aqueous ammonia is also called ammonium hydroxide solution. So if you dip the glass rod, you can now see this showing a white film. So it's going to be something glaring. I will be making videos on these experiments as performed in the laboratory. So keep seeing my channel for more videos. Okay, you can also test for hydrogen chloride gas by adding few drops of silver triazonitrate 5 to the gas jar containing the unknown gas and check. If white precipitate of silver chloride is observed, then the gas is hydrogen chloride gas. Chlorides. Chlorides are normal salt formed when metallic ion replaces the hydrogen ion in hydrochloric acid. Chlorides are prepared by neutralization reaction. Chlorides are soluble in water with exception of fuel. So when we are talking about chloride, we are saying that when a metallic ion is being replaced by hydrogen ion in hydrochloric acid, then it forms chloride. For instance, sodium chloride, magnesium chloride, calcium chloride, and so on. Now, chlorides can be soluble or insoluble. It depends on their nature in water. So we have the soluble chlorides and we have the insoluble chloride. Soluble chlorides include the sodium chloride, ammonium chloride, potassium chloride, calcium chloride. This simply means that all these chlorides there, they are soluble in water. So you can be asked which of these chlorides are soluble in water. It's just for you to get familiar with all this and be able to give the right response. We have the insoluble chlorides, we have copper chloride, we have silver chloride, we have lead chloride. Assignments. Discuss the physical chemical properties of chlorine and hydrogen chloride. Sorry, that's hydrogen chloride, not hydrogen chloride. Hydrogen chloride. Briefly describe the fountain experiment. Thank you. So that will be all for today's class. I hope you enjoyed the class. Please kindly like the video, subscribe to my channel, share this video to your friends, and click on the notification button to always get notification whenever I drop new videos. Thank you. See you some other time. Bye.